Imagine a single wall of ice, stretching 75 miles across and plunging half a mile deep. This is the Thwaites Glacier, an enormous river of frozen water the size of Florida sitting at the edge of Antarctica, slowly sliding toward the sea. This colossal mass of ice is currently being held back by one last floating slab at its front. That slab acts as a physical brake, dragging against the ocean floor and slowing the glacier's descent. But the polar scientists studying this crucial break just issued a stark warning. The shelf is structurally compromised, and it is poised to shatter. According to researchers, this disintegration isn't a distant theoretical possibility. It could begin this very year. In their assessment, it is no longer a question of if, but how and when. You have likely seen the headlines calling this the Doomsday Glacier, often accompanied by internet panic predicting an overnight apocalyptic flood. The reality playing out on the ice is a gradual, multi-generational process that unfolds over decades and centuries. The actual threat is a systemic, mechanical unraveling. Once this physical breakdown is set in motion, it cannot be reversed. To understand the stakes, we need to bypass the hype and look directly at the physical autopsy of a glacier breaking apart from the inside out. Over the last 2 decades, researchers have analyzed satellite data to track the physical deterioration of the floating ice shelf. This diagram tracks the progressive fracturing of the shelf. The total length of these cracks doubled from 100 miles to over 200 miles. It works like a car windshield slowly spiderwebbing with cracks, losing its structural integrity until it is ready to cave in. This graph shows how fast the glacier is flowing toward the sea. From the start of 2020 to early 2026, the ice speed roughly tripled, reaching a rate of over 2,000 meters every single year. One of the researchers reviewing the data described this massive acceleration as, quote, frankly nuts. Spreading fractures and a massive spike in flow speed provide clear proof that the physical break is actively failing. To understand why this is happening, international teams of scientists travel on icebreakers through some of the most dangerous, remote waters on the planet. Once there, they use hot water drills to bore through hundreds of meters of solid ice, punching directly into the black ocean cavity hidden below. Through those narrow shafts, they lower a specialized underwater robot named IceFin into the exact spot where the grounded ice meets the sea. Capturing data in this extreme, hidden zone is the only way to replace mathematical guesswork with the hard measurements needed to calculate exactly when the shelf will fail. Beneath the glacier, IceFin detected warm, salty, deep ocean water creeping inland, actively melting the ice from the underside. As the ice melts, it releases cold, fresh water that mixes with the salty sea. This mixing generates violent turbulence, creating swirling eddies, some measuring miles across, that pump even more warm water deep into the ice's crevices, accelerating the melt in a self-reinforcing loop. This cross-section illustrates marine ice sheet instability. The glacier rests on bedrock that slopes downward inland. As warm water melts the contact point, the ice retreats into deeper water. This exposes a taller, heavier ice face, driving further collapse down the slope. Because of this underlying geometry, the glacier is approaching a physical threshold where its retreat continues automatically, driven entirely by its own collapsing weight. When the eastern ice shelf finally splinters and breaks apart, it will trigger a massive structural shift. Because the shelf is already floating, its disintegration will not directly raise sea levels. It works exactly like a melting ice cube in a glass of water. The liquid level stays exactly the same. The true impact is the loss of the physical doorstop. Without that pressure holding it back, the colossal mass of land-based ice sitting behind it is free to flow outward into the ocean. The danger lies entirely in unblocking the billions of tons of frozen water that are currently trapped on land. The shattering of the eastern ice shelf serves as a starting gun for the glacier's next phase. This event shifts a multi-generational slow-motion slide into a higher, irreversible gear. Scientists are fighting to collect data to determine the precise speed of this ongoing retreat, because that calculation will dictate how and when we must redraw global coastlines. The deterioration of Thwaites is an unstoppable physical march. We don't need to panic about a flood tomorrow, but we do need to prepare for the inevitable changes arriving over the generations to come.